Hi, this is our UROS presentation. Our group was tasked to design, code, and construct a robot to complete various tasks in a given environment. Each task will reward us with a certain amount of points. The objective of the competition is to score as many points within a time limit. We were given 2 motors, 1 servo motor, a VEX Cortex, a VEX controller, a lithium battery pack, and charger. Also available to us is the program Robot C and the VEX Store components. Robot C is a program used to code our wanted commands onto the VEX Cortex and controller. The VEX Store lets us purchase our needed components to create a robot. The constraints to this competition is as shown. During our design process, we are given a $200 budget for VEX Store components. We may only use VEX Store components on our robot, and once purchased components cannot be traded or resold. During our competition, we were given no more than 3 touch interferences. We must at least have 2 drivers, and there was a 4-minute time limit during the competition. These were the available tasks. We were given 5 tasks: climber rescue, hazmat disposal, avalanche mitigation, tower demolition and construction, and the London Bridge. We had chose to do 4 of them: climber rescue, hazmat disposal, tower demolition, London Bridge.
Originally, we had considered using wheels on our robot with the potential of the use of tank steering. But after long discussions and a few Google searches, it was decided that our bot would look like a British Mark I tank with the use of treads. Originally, the drive gear was located on the frontmost top gear. However, because the motors are relatively heavy compared to the frame, this raised and pushed the center of gravity forward. As a result, the robot had some trouble climbing over obstacles with a low coefficient of friction. To fix this, the drive gear was relocated to the lower front gear, allowing us to climb over obstacles much easier.
In terms of the elevator, our system is based on a rack and pinion design. We placed a rack gear on 2 opposite side standoffs so that the C-channels that held our claw would have as little friction as possible while being stable enough to move up and down consistently. The smaller channels allowed us to mount our claw much lower than our original design. We had 2 different mounting ideas where our claw should be placed, and we ultimately decided to go for a lower mount in our tank because it made it slightly easier to push some obstacles to their destination, and it was also easier to pick up objects closer to the ground with a lower mounted height. We initially picked a claw that didn't have a ratchet design because it affected the way our servos were clamping. The servo was geared down to generate more torque. Without a step down, our servo would actually end up not opening up wide enough to pick up our bricks or have the clamping force necessary to hold our wooden blocks. A fun fact is that we ran out of Keps nuts, so we had to use an extra motor screw and the threads of an unused shaft collar to help mount our C-channel to the claw.
While preparing for the competition, we decided that the best way to split up the task we were intending to complete was to have the first driver remove the hazardous waste and then focus on rescuing the mountain climbers until the 2-minute mark, since we figured that the best time to hand off the controller would be while depositing the climbers at the hospital, since the controller could be passed without the robot dropping a climber. The second driver would then use the rest of the time on tower demolition in the first round to try to guarantee a solid score, and then make an attempt at the bridge in the second round to score higher if possible. Rescuing the climbers would give us 600 points, while the hazmat moved from the starting zone would prevent a loss of 200. Then, depending on remaining time, we would either gain an additional 400 from the bridge or as many 25-point additions as possible. Overall, we performed relatively well. Our robot had no major malfunctions and ran through the course smoothly, succeeding the task we planned to accomplish with only 2 major hiccups, a touch interference in the first round and a dropped climber in the second. We were unable to complete the bridge, but got a reasonable amount of tower demolition done in both rounds. In reflection, 3 major factors determined our success during the competition, the first of which was practice. Our performance was limited by mistakes made while piloting the robot and a lack of practice with the specific objects we manipulated during the competition, rather than major design oversights or issues like wobbly wheels. Second, our design process, which yielded a very sound and effective robot. Despite not getting as many points as we would have liked, our robot itself functioned nearly perfectly during the competition, experiencing only minor difficulties related to the USB cord connecting to the controller getting caught in the robot's treads. Holding the controller higher up fixed this issue in round 2. Third, using all the available information. I believe we made use of most of it, but when we practiced with the robot, we used things like paper towel tubes and Nerf darts rather than wooden blocks and Lego minifigures, as we knew would be used during the competition. Had we gone out of our way to use objects identical to the competition objects, we may have had a better idea of our robot's limitations while manipulating them and been able to be more efficient. Beyond the experience working with metal parts, motors, and coding, we had a few key takeaways. We found that documenting changes and decisions was very helpful for keeping everyone on the same page, which took the form of taking notes during team meetings, taking videos of the robot completing tasks or failing to complete them, and distribution of this information through a pair of group chats we made specifically for communication and documentation. Occasionally, since not all group members were able to be present at every group meeting, this was easily remedied by keeping track of changes and progress made and updating absent teammates through the group chats. Additionally, we were satisfied with the route we found to arrive at a final project, which was to spend a relatively large amount of time designing and discussing before assembling and purchasing parts to minimize troubleshooting on our physical robot. This allowed us to be very cost efficient, only ending up with a couple bits of spare hardware and a pair of sprockets that weren't used on our final design. Finally, allowing group members to play to their strengths, which was one of the first things we discussed as a team, made collaboration and delegation happen more naturally and ultimately allowed us to be more effective.